Hey guys, I hope you're all doing really well. So, over the past few weeks, I've been doing some of the micro courses to get me started with machine learning. And I figured why not get started with a personal pleasure project of mine. So, since I am a big fan of the FIFA game, and there is the data set of FIFA 20 available on Kaggle, so that's what I decided to go ahead with. So, let me get to the project straight away. So you have a player card and the player predicted stats. So what basically is the objective of the project is of the program or the machine learning model is that you feed in the data, you give him some of the preliminary stat values like the age of the player, the player's height in centimeters, the weight, the international reputation that the player has, his weak foot ability, the skill moves, and a few other, the nationality and his work rate and the club which he signed with. So these are some of the inputs which are treated as the feature that is passed on to the model and trained, and later on the model works and churns out the value. So what you can see is the calculated value from the model that I have used for this project. So you have the player based stats which is predicted, the future potential of the player, the value of the player, and the wage that the player earns. So before I get into the detailed analysis of what the project actually is, let me just show you how the input works. So here you can see the first thing it asks is the first name. So I just entered John Doe. So John is 23 years old and his height is around 6'2", so that's 187 centimeters. He weighs at about 95 kilograms and enter the player's international reputation. So how reputed is the player? So let's give him 5. He's highly renowned. Enter the player's weak foot ability. The player is really excellent. So let me give another 5. Enter the player's skill moves. So let's try something different from what I've done before. Let me make his skill moves as mediocre. So a mere 3. And then it asks for the player's nationality. So, well, since I'm an Indian, I'll pass India. So what's the work rate of the player? So here you have three options and a different combination of an attack versus defense. So I'll just go with a high work rate for attack and defense, and it asks for the club that the player is signed with. Now, since I'm an Arsenal fan, I'm going to put Arsenal. And here are the calculated values. So as you can see, the basic biodata of the player is mentioned over here. And the player predicted stats. So the player base stats, that is the stat the player begins the game with. That is 81 with a margin of plus or minus 1.45. So the 1.45 is the mean absolute value, mean absolute error that is calculated. The future potential of the player is the stats the player is going to carry throughout the career towards the end of the career. So that's around 85 with the plus or minus of zero point 0.5. The estimated value of the player. So the player is valued at 21.92 million euros, and the wage that the player earns is 65,487. So I have also mentioned the margin of error or the range within which the value may fall, and this is calculated according to the mean absolute value which is presented by the model that you can calculate. Now, let's go into the deep diving and how I came up with this. So, I was browsing through Kaggle and I came up with the FIFA dataset, and I realized, yeah, why not? Why not work with this and make something up? So, the CSV files that are available in the dataset that I got were players 16, player 15, 18, 19, 20, teams and leagues, and players 17. So what these are basically the file names. So I chose to work with players 20. So whatever the data that is generated, the input values that you give and the output that you receive is all calculated based on the values, the initial input of the features that were given by this file. And I have created a data frame and added the file. So I'm not going to get into the detail of it. I'm just going to brush through. So here I'm just making a list of the columns and then checking the kind of output they have, how I would like to go ahead and distribute. So the first thing is the distribution of the feature. So what I have done with my project over here is that the first thing that I calculate is the overall, that is the base stat. And with the base stat that I calculate, I use that as an input to calculate the potential. And then the overall and the potential are used to calculate the value. And the three together are finally used to calculate the wage of the player. So it's kind of like an incremental step. And then these are just how you encode. So the thing with the machine learning model that I have used is that it mainly works on integer values. So it does not have arrangement or ability to work with non-integer values. So you need to encode them. So that's what I was approaching to do over here right now. So as you can see, I have encoded the value. Well, the first thing was to find out the columns which have non-integer values. And once you've separated them out and you find out that the nationality, the work rate, and the club are the columns that hold non-integer values, the next thing is to encode them. So usually what people do is they split the data into test data set and training data set, and then they try to encode it. But what happens in that case is that sometimes in the test data set you come across a value that may not have been in the training data set, so it's not able to transform accordingly. So this is, as a beginner, this is the approach I chose to go with. I encoded the variables first, and then I went ahead and I split them. And now, so when you're entering the values as a user, you do not know what those integer values stand for. So what I had to do was create a dictionary where the non-integer value, had to be mapped to its corresponding integer value. And that's what I went ahead and did over here. And as you can see, that's the country dictionary. So for the country code and the country name, the country code is the integer value of the encoded model. And then you have the work rate and the club. So these are just the name mapped to the corresponding integer value which have been label encoded. And these are basically just a few checks, like as I have been progressing throughout. And finally, let's get to the main crux of it. This is the part where I split the data. And this is the model that I have used to train my data set. That is the XGB regressor. So what I have used over here are the N estimators and a learning rate of 0.05. So these are basically the parameters that you feed into the model based on which the model trains the features that are passed into it. Well, I am brushing through and I'm going at a really fast speed. And I just want to go on the surface level of what I have done and give you an idea. And then you have the mean absolute error. That's basically the margin value which I showed to you guys at the end, the margin rate. So that is what I'm calculating over here right now with my mean absolute error. And that is for the four models that I've passed: the base stats model that calculates the overall value, the potential model that calculates the potential of the player, and the player value and the player wage model. So these are the four models that I've used. So while training the model, I have used the four data frames, if you will, and I've passed them into the model. But the calculation, the output part of it comes when I'm checking it back towards the end. So as I come down here, all of this is just my checks, and these are just the basic input. The main uh, calculation part, if you will. So the value that are accepted are passed over here in the form of a data frame into the predict function. So first I calculate the overall by predicting it from the base stats model. Then I use this overall and I insert it in the second list, which is passed as an input for the potential. And then I predict the value of the potential and so on and so forth. And I calculate the four values. And voila, you have your program. So this is a generic skeleton version of what I intended to do with it. And since it's a pleasure project and I have been able to come this far, I'm really proud of myself that I've been able to do this and I wanted to share this experience with you guys. And so, yeah, let me execute it once again. What name can I give? James Harper. Let's make him a young lad who's just starting off. And what's his height? So let's make it 185 and he weighs at about 90 kilograms. Let's make this player exceptionally good. So he's a 5, a 5, and a 5. So that's the international reputation is 5. The weak foot ability and the skill moves ability are all 5. Okay, so nationality. So let me make him Spanish, Spain. Or is it Espanol? I have to check it in the data set. But let's try. If there's an error, we'll find out. High, obvious since he's a good player. High. Okay, so no, that was not the right one. High. And he plays for Barcelona. Let's see what he sums up to. Okay, so, well, that was unexpected. Well, okay, so it is FC Barcelona. Let's just put Arsenal. That's like a one word club name. Let's go ahead with it again. Let me execute it again. So, James Harper. He's 19 years old and he is at 185 centimeters, weighs about 90 kilograms. He's an has a good reputation, good weak foot ability, and highly skilled. He is from Spain, has a high work rate. Well, I shouldn't put any errors while typing because I haven't done any back workaround for them. And let's put FC Barcelona. Okay, so here you have your output. James Harper, age 19, Spain, FC Barcelona. Okay, let's see his stats. His base stats is 80, and his future potential throughout the course of his career is 88. He is estimated at 22.67 million currently, and his wage is 31,558. So, this is basically how the program works. And once again, thank you uh, that I've been able to share my experience with you all. And I hope I work on this and get much more far ahead. All right, bye.